Hello. Here is our second to last lecture. We're going to be continuing kind of our introduction to calculus. We're going to be talking today about approximating the derivative. All right. So just to remind you what a derivative is, the derivative of a function, let's call that function f of x, is the slope of the tangent line at a point on the function. Okay, so let's say that we have some function that looks like this. So let's say that we want to plot f of x is equal to x cubed. All right, so we know that it goes through 0. There's a point at kind of 1, 1. There's a point at -1, -1, and it looks something like this. Okay, so that's our x cubed function. So let's say that we wanted the derivative at x equals 1. So what you would do is you identify the point, and then you would draw a tangent line to that point. So tangent is where it just crosses that point. It just touches at that point, and it kind of symmetrically moves away in either direction. So something like this. Okay. So that would be the tangent line, and the derivative would be the slope of the tangent. Okay. All right. So some notational things that I want to talk about first are the derivative usually is either written one of two ways. So you'll see it is either df of x dx, or you'll see it written dy dx. Okay. And in this lecture, and in calculus probably, you'll see this used a lot, where kind of y is used interchangeably with f of x. So if you see f of x, what this means is the function evaluated at x gives basically its y value. All right. All right. So let's first talk about the slope. Okay. So how do you calculate the slope? So if you remember, if you have 2 points, you can calculate a slope between those 2 points. So let's say this is point x1, y1, and x2, y2. And if we draw a line between those points, the slope is equal to, if you kind of draw a line, this is called the rise. This is called the run, right? So how much far do you have to go in x, and then how much do you need to go in y? All right, so the slope is equal to the rise over the run. And the rise basically is how much the y values change. I forgot parentheses here. So this would be like the y2 minus y1. So the y value of this point minus the y value of this point over x2 minus x1. All right, which is the x value here minus the x value there. Sometimes, again, I said this before, but the way we're going to kind of think about this is f of x1, which is the x of x2, which is the y value at x2, minus f of x1, the y value at x1, and then this is x2 minus x1. So that's how we calculate the slope. So I'm going to do an example. So let's say that we have 2 points, all right, and let's say there's a line between them, and the points are, let's say 2, 8, and 1, 1. All right, and what we want is we want the rise over the run. All right, so the rise value is going to be basically the difference in y value. So this is going to be 8 minus 1, which is 7. And then the run is going to be the difference in the x value. So that's going to be 2 minus 1, so which is equal to 1. All right, so the slope would be equal to, here I'll just kind of follow this equation. So this would be 8 minus 1, so y2 would be 8, y1 would be 1, over x2 minus x1, which is just 2 minus 1. So x2 is 2, x1 is 1, and we get 7 over 1, so the slope would be equal to 7. All right. All right, so that's the slope. So the derivative is basically finding the slope of the tangent. So the derivative is the slope of the tangent line. All right, so here's a weird idea, and this is kind of a weird idea, and I'll kind of break it down for you. One is that to find slope, you need 2 points. So this would be like our x1, y1, and x2, y2, to find the slope. So slopes, by definition, you need 2 points for them. The derivative is the slope at 1 point. Okay, so remember the tangent is a line that touches the function at just a single point. So we're asking, when we say the slope of the tangent line, we're saying we want the slope given only 1 point. So there's an inherent contradiction here, which is that you need 2 points to find the slope, but the derivative is basically the slope at a single point. So how do you figure out that? And the answer is, and this is kind of the key to this, if you remember the name of this, is that we must find the derivative by approximation. Okay, so the whole idea behind this is that we're going to find the slope at 2 points, but we are going to move the points closer and closer together. Okay, and the whole idea behind this is that we can find the slope for 2 points, but not a single point. But as we move those 2 points closer and closer together, it'll be more and more, it'll get closer and closer to the derivative of the slope at a single point. All right, and this whole idea is that technically you can't find it directly, but you can find the approximation to it by just moving those 2 points closer and closer together. So that's what we're going to do. So we're going to give some function. So let's say that we have a function f of x, and the one that we're going to use for this example is 1/2 x squared minus 3. And we're going to find df dx at x equals 2. All right, so we want the derivative at a single point where the function is equal, has a point x equals 2. So this would be at some point, 2 and then f of 2. All right, so at that point, whatever that evaluation is, that would be the point where we want to find the slope. All right, so what we're going to do is we're going to do an approximation. And we're going to look for the trend. All right, so the points that we're going to use, so first we're going to use x equals 2, and then we're going to use x equals 3. So the point where So technically this is like 2 f of 2 and 3 f of 3. So we're going to use those 2 points to find the slope. And then we're going to move them closer together. So x equals 2 and x equals 2.5. So you can see they're getting closer together. So this is 2 f of 2.5 and 2 and f of 2 and 2.5 f of 2.5. And then we're going to get even closer. We're going to use x equals 2 and x equals 2.1. So those points are 2 f of 2 and 2.1 f of 2.1. And then our final approximation, we're going to use x equals 2 and x equals 2.01. And these are points 2 and f of 2. That's basically its y value, right? And then 2.01 f of 2.01. All right, so we're going to find the slope. So we'll have the slopes for each of these. So we'll have slope 1, slope 2, slope 3, and slope 4. And the whole idea behind this is that as these 2 points get closer together, so this is 2 to 3, 2 to 2.5, 2 to 2.1, 2 to 2.01, we'll get closer and closer to the slope of the tangent at x equals 2. All right, so that's how this is going to work. So graphically, what that looks like is, I'm not going to draw this real carefully at this point, but our graph is going to look something like this. I guess I'm going to draw it sort of carefully. So our graph is going to look something like this. All right. And what we're trying to do is we're trying to find the slope of the tangent at this point right here. Okay. So if we zoom in, so we just look at kind of that curved portion. Right? What we want is we want the slope of the tangent at this point right here. But what we're going to do is to first start off with, we're going to pick 2 points that are kind of close. So we start off with, let's say, x equals 3 and x equals 2. And then we'll find the slope of the tangent line that connects these. So I'm going to use this kind of chopstick here. But you can see that those 2 lines are not, those slopes are not the same. So this one's kind of steeper and that one's less steep. But what happens is as we pick points that are closer and closer together, you see if I pick this point and this point, that those 2 slopes are getting closer and closer. If I pick 2 points, those 2 look almost identical, right? And then as I move this point in closer and closer together, I should get closer and closer to the slope of the tangent line, and that should be our value. All right, so that's what we're going to do. We're going to find the slopes for these points, and then we're going to see if there's a trend in those values of the slope. So let's get started with that. All right, so let's do approximation 1 with x equals 2 and x equals 3. Okay, so if you remember, the slope is f of 3 minus f of 2. Those are basically the y values minus 3 minus 2, right? So I'll just write the general equation. Slope is f of x2 minus f of x1 over x2 minus x1. All right. So in order to evaluate this, what we first need to do is we need to find f of 3 and f of 2. So let's do that over here. So let's do this in blue. So f of 3. Let me just remind you what our function is. So f of x is equal to 1/2 x squared minus 3. Right, so f of 3 is basically you evaluate this by plugging in 3 for x. So this is 1/2 3 squared minus 3. So you can calculate that value. But here, I'll just do it. It's 1/2 times 9 minus 3, which is 9 times 1/2 is 4.5 minus 3. So this is 1.5. Then let's calculate f of 2. So again, we take this function and plug in x equals 2. 1/2 2 squared minus 3. So this is 1/2 times 4 minus 3. 2 squared is 4. And this is 2 minus 3, which is minus 1. So if we plug that in here for our slope, we get, I'll put these, 1.5 minus -1 over 3 minus 2. And when we calculate that, we get this turned into 1.5. This is a double negative, so that's plus 1 over 3 minus 2 is 1. So this is 2.5 over 1, so the slope is 2.5. Okay, so that's our first slope. Let's continue on. We'll just continue this approximation. So approximation 2 is x equals 2 and x equals 2.5. So the slope is equal to f of 2.5 minus f of 2 divided by 2.5 minus 2. All right, f of x2 minus f of x1 over x2 minus x1. So let's calculate f of 2.5. All right, so f of 2.5 is we take the equation and we just replace x with 2.5. So 1/2 2.5 squared minus 3. So at this point, what I would suggest you do is I would suggest you just get your calculator out. So I'm going to do this in my calculator. So I get 1/2, which I'm going to write as 0.5 times, I'm going to put in parentheses, 2.5 squared minus 3. And I get 0.125. All right, and f of 2, we already did f of 2 up here. It's the same calculation. F of 2 is equal to -1. All right, I could redo it, but I've already done it. So let's plug those values in, and I get 0.125. And also, I would suggest when you do this, just keep a bunch of decimal places. If you can actually store it in your calculator, that's even better. Minus -1 over 2.5 minus 2. So this is this becomes plus 1 because of double negative. And I get 1.125 divided by 0.5. So if I do that calculation, so here I'm just going to add 1 to this and then divide by 0.5. And I get 2.25. So you see, for my approximations, it started at 2.5, then it went to 2.25. So we'll continue the trend. Oh, I need more paper. Okay, so let's do approximation 3. So approximation 3 is x equals 2 and x equals 2.1. So our points are getting closer together. So the slope is f of 2.1 minus f of 2 over 2.1 minus 2. So let's calculate, and again here I'll write our function up here. F of x is equal to 1/2 x squared minus 3. All right, so we want to calculate f of 2.1. So this would be 1/2 2.1 squared minus 3. So if I put that into my calculator, let's clear this. I get half is 0.5 times, I'm going to put this in parentheses, Technically, I don't need this parentheses, but I'm just going to put it in just to be extra safe here. And I get negative 0.795. All right, and f of 2 I already know is negative 1. So let's plug those numbers in. So I get negative 0.795 minus negative 1 over 2.1 minus 2. So again, this becomes positive. Negative 0.795 plus 1 over 2.1 minus 2. So I have this this number already. I'm just going to do plus 1. And I get 0.205. And 2.1 minus 2 is 0.1. So if I take that number and I divide it by 0.1, I get 2.05. All right. And then let's do our fourth approximation. Which is x equals 2 and x equals 2.01. So we're getting closer and closer to this point with x equals 2. And the slope is f 2.01 minus f of 2 over 2.01 minus 2. Hopefully you see the pattern here. So f of 2.01 is equal to 1/2 2.01 squared minus 3. And let's do that calculation. So if I do that one, let's clear this. I get 0.5 times 2.01 squared. Well, here, let me put this squared minus 3. And I get negative 0.9795. All right, so I'm going to keep all those decimal points. It turns out they're important. F of 2 I already calculated is negative 1. So this value is negative 0.97995 minus negative 1 over 2.01 minus 2. So this is going to be plus 1 again. So I'm going to have this plus 1 is 0.02005 divided by 0.01. So when you divide by 0.01, that's the same as multiplying by 100. And this is 2.005. So maybe you could see where these values are getting closer to, but I'm going to try to summarize it for you. So looks something like this. So let's create a table. So we had, so our slopes, our first one was f of 3 minus f of 2 over 3 minus 2. So the slope for that one was 2.5. All right, and then we have f of 2.5 minus f of 2 over 2.5 minus 2. And the slope for that one was 2.25. And then we had f of 2.1 minus f of 2 over 2.1 minus 2. And the slope for that one was 2.05. And then we have f of 2.01 minus f of 2 over 2.01 minus 2. And the slope for that one was 2.005. All right, so maybe you could see the pattern here is that as those points get closer and closer, the slope approaches, if you can see the pattern, it's getting closer and closer to 2. So what we would say is the way you would write this mathematically, and we're going to kind of talk about this, is that we're going to say the derivative df dx is equal to so I'm going to write it first, and then I will kind of explain what this means. So it's a limit as h equals 0 is f of x plus h minus f of x over x plus h minus x. And over here, one of the things you might be able to see is that this kind of x cancels out with this. And so normally the way this is written is like this. Limit as h goes to 0 of f of x plus h minus f of x over h. All right? So if you look at this, this is just kind of a general way of doing what we just did, which is that we have some value, let's say x equals 2, and then we're adding a little bit to it, right? So in this case, we added 1, 0.5, 0.1, 0.01. So we're adding a little bit extra. So this h is like the added value. Right? So we take our number and we just add something to it in 1, 0.5, 0.1, 0.01, and that's what h is. And then if you notice when each of these, that value 3 minus 2 is 1, 0.5, 0.1, 0.01, that value we add is actually the denominator. And what we're saying is the derivative is as this little added value gets smaller and smaller, so as it approaches 0, this is going to be closer and closer to the slope of the tangent. And in our case, that value, I'll just use in blue, happens to be equal to 2. All right, and we did that just kind of numerically. You can kind of see the pattern. If you want, you could go even smaller, 2.001, 2.00001 if you wanted to. And as long as your calculator can carry enough digits, basically what you'll find is that this thing gets closer and closer to 1. I mean, closer and closer to the value 2, which is the tangent at that point. All right. So I think the first 6 questions or something on your homework is basically this process. All right, so we found the slope of the tangent at one point, but one of the things that is really nice to be able to do is to find the slope at any point. All right, so we're going to find the derivative symbolically. All right, so we're going to find the derivative symbolically. And the idea is that instead of the derivative at just one point, which in our case was x equals 2, y equals -1, at that point we're going to just use x. If we just used x, then we could find the derivative equation for any value of x, right? So instead of just using 2, we can just figure it out for any value of x. And that's kind of what this h equation was from before. So I'm going to write this in here. I'll write this in blue. So for example, like the slope, before we use something like f of 2.01 minus f of 2 over 2.01 minus 2. And then what we're going to do is we're going to generalize that. So we're going to generalize that to an equation f of x plus h minus f of x over h. Okay, so instead of using a specific value, which in this case is 2, or a specific change, an added value, which is 0.01, we're just going to use x and we're going to use h. And that'll give us the derivative, or the slope of the tangent at any value of x we choose. So if we plug in x after we do this calculation, we'll have an equation for the derivative rather than just a derivative at just that one point. Okay, so x is any value, so any value that the graph in the graph's domain, and then h is a small added value. Okay, so that is what we're going to do. Now, if you look at this, we have basically our old friend. So f of x plus h is the composition function. Of f of x, and so f of x is equal to 1/2 x squared minus 3, and let's say g of x would be equal to x plus h. So what we're looking for is f of x plus h is essentially the composition f of g of x. All right. So that's basically what this first term is. And so when people run into difficulty with doing this calculation, it's usually because they have difficulty with the composition function. But this essentially is just a composition function of those two. I think I said this before, but I hadn't really thought about that before this semester, about how important this composition function is. And the next time I teach this, I'm going to put more emphasis on this. But it kind of shows up all over the place in this course. But that's what we're going to do. We're going to just find this composition, and then we're going to try to evaluate this equation. All right, so I'm going to write the equation that I want here. So we want f of x plus h minus f of x over h. All right, so we're going to take this step by step. So first step is we're going to find f of x plus h. And I'll just write f of x is equal to 1/2 x squared minus 3. All right, so in our case, f of x plus h, if you remember how to do this composition, is basically what I do is I start off by taking this function, and I just leave kind of an empty space. So if I replace x with an empty space, 1/2 x squared minus 3. So instead of writing x squared, I just leave an empty space here. And then it's f of x plus h. So what happens, actually, let me do this in a different color. X plus h, let's make believe I was in red, would be 1/2. And then in that empty space, I'm going to put what was in here, x plus h. Okay. Then I have to do some algebra to evaluate this. So let's go through the steps of that. So if you see this, it's 1/2. I'm going to just leave this in blue. X plus h squared is x plus h times x plus h minus 3. So this x plus h plus x plus h, this is FOIL. So first, outside, inside, last. But basically, it's you do the two distributions. Distribute x with these, and then distribute h with these, and leave the half out front. We'll take care of that later. But if you do this, you get 1/2 x squared plus hx plus hx plus h squared minus 3. So now you have this 1/2. So you have to distribute this 1/2. Oh, actually, let me do one other step. This hx plus hx becomes x squared plus 2hx plus h squared minus 3. And then we're going to distribute this half now. So this half gets distributed to each of those terms. And we get 1/2 x squared. And then this 1/2 times 2, hx becomes, if you take half of something multiplied by 2, is just equal to hx. And then half times h squared minus 3. All right, so that's our f of x plus h. All right, here, let me just circle this or box it. And then step 2, we'll kind of work our way through this. And your homework also does this as well. Kind of it does step by step. Let's calculate the numerator. F of x plus h minus f of x. So what we're going to do is we're going to plug in. So f of x plus h is this expression. 1/2 x squared plus hx plus 1/2 h squared minus 3. And then we have a minus f of x, which is just this equation. I'm going to put this in parentheses, so this is an important step, because we're going to have to distribute this minus sign. So this minus sign comes in. I put this in parentheses because it needs to be distributed to each of those terms. And then we're going to get some cancellation here. So we get 1/2 x squared plus hx minus 1/2 h squared minus 3. And it becomes minus 1/2 x squared. And then minus a negative 3 becomes plus 3. And what you can see here, we get cancellation. So half x squared cancels with negative half x squared. And then negative 3 cancels out with positive 3. And we end up with hx minus 1/2 h squared. All right, so that would be our numerator for this. So we're working our way up to this equation over here. So let me just write this equation again at the top. F of x plus h minus f of x over h. And f of x is equal to 1/2 x squared minus 3. So then our third step is we're going to calculate this. F of x plus h minus f of x over h. So before we know that the numerator of this, step 2 was calculating this numerator. This numerator is equal to this value, hx minus h squared, and then the denominator is divided by h. Okay, so from this step, what we're going to do is we're going to cancel out common factors of h. So what happens is this h cancels. So you have to, well, actually, let me take in one more step here, which is that you would take, if you have something like this, you divide each term by the denominator. Okay, and then we can cancel out common factors. So we have an h, cancels out with this h. H squared over h, the square value cancels out, this denominator cancels out one of those. So what you get for this is you get x minus h. All right. All right. So our fourth and final step is we know that the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. So basically what we're looking for is we're looking for the limit as h goes to 0 of x minus h. So you can see here basically what this step is we're going to make h equal to 0. And when you make h equal to 0, then what that means is that the derivative is equal to x, right? X minus 0 is just x. And in this particular case, that is the derivative, right? So we just found, for example, when we did this earlier, when we were doing this approximation, we found that the derivative at x equals 2 was equal to 2, right? And that turns out because whatever value you pick, whatever value of x you pick, happens for this equation happens to also be the slope. Okay, so when you take calculus, what you'll find out is that people did this. Well, all right, so let me point out one other thing before I get to that. Is that for this value, we can find the slope of the tangent at any point if we know its x value. All right, so that's really the key to doing this symbolically is basically you get an equation for the derivative rather than finding the derivative at a single point. Right, so we did a x equals 2, y equals -1. That's the slope of the tangent at that one point. But you could tell me any value of x, and I could tell you the slope of that equation using this. So if you say, what is the slope of the tangent at x equals 2003 and f of 2003? And I could say, well, the slope, according to this equation, is just going to be 2003. And so that's what's cool about this equation. It doesn't have to always be at x. So I'll just do a sidebar. But basically, there is, when you take calculus, you'll probably do maybe an example that's very similar to this. But you'll see that there's a pattern, which is that if you have some f of x, which is, let's say, x to the n, right? Some x to the n power, the derivative turns out will always be n x to the n minus 1. All right, so we had an x squared. So the derivative of x squared is 2x, but we also had another half, so it cancels out. And then you also find out the derivatives of constants doesn't change the slope. And the reason why it shouldn't change the slope is because that just shifts it up and down. It doesn't change how steep or flat it is. But that will be something that you see in calculus. You probably we'll go through something like this for different functions, and you'll see that it always ends up being something like this. Okay, so you should have enough to do your homework, but what I'm going to do is I'm just going to give you one more symbolic one, just to give you another example of some of this algebra. So let's say that we have f of x is equal to 3x minus 2 squared. All right, so this is where the algebra is a little bit more difficult, but it's the same procedure. Is we're looking for df dx, which is the limit as h approaches 0 of f of x plus h minus f of x over h. All right, so the first thing we want to figure out is f of x plus h, the composition. So basically what happens here is we get 3, and then instead of x gets replaced with x plus h. All right, and we have 3 terms here. So that squared just means it gets multiplied by itself. And then basically we're going to have to distribute. So we distribute this x to each of those terms. We're going to distribute this h to each of those terms. And then we're going to have to distribute this negative 2 also. So it's kind of a distribution. We're going to distribute just kind of all over the place. All right. So I'm going to write over here so I have a lot of space to do this. So the 3 just hangs out here. I put a square bracket. So x times x is x squared. X times h is hx. X times negative 2 is negative 2x. And then let's distribute the h's. H times x is hx. H times h is h squared. H times negative 2 is negative 2h. And then we distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times h is negative 2h. Negative 2 times negative 2 is positive 4. All right. So I told you the algebra was a little bit more complicated, but what we're looking for now is let's combine some common terms. So we have some hx's, right? So this and this we can combine. We have a negative 2x and a negative 2x. So we can combine this with this. And then we have negative 2h and negative 2h, so we can combine these two. All right, so what that gives us is 3 is still hanging out here. X squared, and then here we're going to get 2hx. This negative 2x and negative 2x is negative 4x. And then we get an h squared. And then we get a negative 4h when we combine the negative 2h and negative 2h. And then plus 4. Now we need to distribute the 3 to all of these. So let's distribute this 3. So when we do all of that, we get 3x squared. By the way, the one on your homework is not this complicated, but I just want you to be aware of kind of the complexity of the algebra for some of these. 12x plus 3h squared minus 12h plus 12. All right, so that is our f of x plus h. All right, then what we need to do is find f of x plus h minus f of x, but f of x itself is not that straightforward. 3x minus 2 squared. So let's calculate this. So 3 times x minus 2 times x minus 2. This is a straight up FOIL. So we get is 3 times x squared minus 4x plus 4. Okay? And then we have to distribute the 3. So if you're looking at this and you're like, there's no way that, you know, he could expect us to do this algebra. Basically, this is what you should expect from calculus. Okay, so we have these two expressions, and we want f of x plus h minus f of x. So just know what you're getting into when you take calculus. Is basically that's what this is. So we're going to do the numerator of this. So f of x plus h minus f of x is equal to, it's a long expression. So this first one is 3x squared plus 6xh minus 12x plus 3h squared minus 12h plus 12. And then we're going to do minus 3x squared minus 12x plus 12. All right. So this minus sign kind of distributes in here. So if I distribute this minus sign in, I'm going to save some space here by make it positive, and then it switches the sign of all of these, right? So this becomes negative. And when we do that, the 3x squared cancels out with this 3x squared. This negative 12x cancels out with this positive 12x. And this positive 12 cancels out with this positive 12. And you get 6xh plus 3h squared minus 12h. So that's our numerator. And then we have f of x plus h minus f of x over h. 6xh plus 3h squared minus 12h over h. And I'm going to take each of those and divide each term in the numerator by the denominator. 6xh over h plus 3h squared over h minus 12h over h. And we get a cancellation. And so this becomes 6x plus 3h minus 12. And then finally, the last step is the derivative, df dx, is equal to the limit, as h goes to 0, of f of x plus h minus f of x over h. So the limit, h approaches 0, of 6x plus 3h minus 12. And as h approaches 0, basically this becomes 0. And so the derivative of this is 6x minus 12. Okay, so we have some function f of x, which is 3x minus 2 squared. And when you took the derivative of that, we get that the derivative was 6x minus 12. All right, and if you know the rule for this, for the derivative, that's true because the 2 comes down, so you get 3 times 2 is 6, and then 6 times parentheses x minus 2, 6x, and then 6 times negative 2 is negative 12, so that is the derivative. All right. All right, so that's not on your homework. That's not going to be on your, I'm not going to put this one as complicated as this on your final, but hopefully it gives you an idea, if you're headed toward calculus, the types of algebra and things that you'd be asked to do. The homework starts off is you do kind of this approximation of calculating slopes between 2 points as they get closer and closer to x equals 2. And then you have to do this, this composition. But the whole idea is you just do it in parts. So first find f of x plus h, Then find f of x plus h minus f of x, and then divide by h, cancel out common factors of h, and then set the limit h goes to 0 to get rid of those terms that have h in it, and then you get your derivative. All right, so I hope you're well, and I'll talk to you next time. We have one more lecture.